Alright, welcome to a quick video. I like these design ones, so let's keep at it. I'm gonna start my senior project soon, so I might record those instead pretty soon. But I'm gonna still do code because I want to, and yeah, I'll just be doing those. Because there's also peak recruiting, so hopefully I can be still sharp when those come around. Alright, let's see. Coding practice. Shortest word distance to design a data structure that we initialize with a string array and should answer queries of the shortest distance between strings from the array. What? So you initialize this, then you call coding practice, then you call makes coding, and it should return 3 because what does the distance mean? Coding. How far does so it's coding is 1, 2, or is it 1, 2, 3? 1, 2, 3. Okay, so the distance between how far apart they are, and makes is makes and coding. One, 2. Oh wait, hold on. 1, 2. Oh, I see. Makes and coding. So you start at makes. Okay. So makes perfect coding. Okay. Makes and coding is 1 because of this. So there's a makes here. So there's 1, 2. Technically would be 2, but this is 1. Okay. What I'm thinking here is to have like a hash map, right? Make okay. Hash map where I'll store the index, so the word itself, practice, with an array of all the indices. So there's only 1 for this one, and there's 2, 3, 4, 5. So all right. So we have practice, makes, but makes x2 has 2. 0, 1, 0, 1, 2, 3, 4. So 4, right? We can pick that, right? We'll also have, okay, we gotta do another one here. Okay, we have makes, perfect, that should be index 2, 0, 1, 2, and then We'll have another coding, which is 3. And another makes, which is 5. Nah, that's already written. So like that. So then when we're given a word, so for example, in coding, we're going to get coding and get the smallest value. Oh, shoot. Let's do this. Let's try all the possible ones that makes is close. So I'm going to start. This is the starting point. So get coding. So coding is going to be 3 minus practice. So 0, which equals 3. So that's why we return 3. Then we'll do makes and coding. So makes is we'll start with 1. We'll do 1 minus then the other one coding, which is 3. So this is gonna equal 2. We'll do ABS instead. So it'll be 2, right? But we have more, so we're gonna keep trying. So we're gonna try. We'll also try 4. ABS 4 minus 3, which is gonna equal 1. So then we return the smallest one, I guess. In the case there's like more than we do want to try every combination, so that's the hard part. That's why I do want a linear solution, but what do you want to maximize? Like the biggest number? Like I can't call anything that, you know? Like I might have to try like everything. It might be a case where there's might be another one like 2, right? And let's just say this is 5 instead, right? And we won't really know, because so it would be like, so makes is gonna be 1. We'll try 1 minus 3. That's gonna be 2. We'll also try 5 minus 3, which is also gonna be 2. And then we'll also try 3. We'll do 1 minus 2, which is gonna be 1. That's the smallest we've seen so far. Then we'll try 5 minus 2, which is gonna equal 3. That's the largest, so we'll keep this one, which is that. So I want to try every single combination, which probably is going to definitely TLE. Yeah. That is the problem. So what could be a better way to do this? Well, one way I can think of this is, okay, where are you, right? So let's say makes is technically at the beginning and end. So which one is closer? Well, makes and coding is closer, so I don't have to return 1. Well, if you think about it, if I did the smallest, yeah, I have to take the difference between the two. I don't know which side to be more biased towards, you know? Well, one way would be to sort it. No, I have to keep it in place. makes and makes. What could we do? What could we do? We have 0, 1. We have 0, 1. Then we're gonna have 0, 1, 2, 3, 4. 0, 1, 2. Wait, okay, so coding is gonna be 0, 1, 2, 3, right? Makes is gonna be 1 and 4. Maybe taking the biggest value possible. Yeah. So take the largest sum here, largest one, and it will guarantee me the biggest one. So I'll try that. Basically, I want the largest number you've got and the largest number you got, and take that will be my shortest. So let's try that. So let's do self.dict. Default list for every word in words. Dict is here, and let's enumerate. I. Yep. That's all we really need. Then I want to return me, or let's do this. Let's do let's do this. Max 1, which is going to be self.dict of word 1 minus word self. Okay, no, we'll do that later. Do another one here, 2, and we'll do 2 and return max 1 minus max 2 ABS. Yeah, but I want the max, so give me max. Max. Pretty straightforward. I don't think it works, to be honest. Yeah, I don't know if I'm thinking about this correctly. So let's see about this one. There's probably something I'm not really considering. For example, we have a list of words here, and then we call the shortest from A to B and B to A. So, I don't know the output of that. What is that supposed to say? 2, 2. Okay, so the output should be 2, 2. 2, 2. Okay, let's try to build this one out. So mapping here is saying we got A occurs in 0 and 1. B occurs in 2 and 3. 0, 1, 2, 3. So yeah. Then we're taking the max of 1, so it'll be 1 minus 3, which will equal 2. What did they call? Oh, they did A and B. So first that's, yeah, so that's 2. Then they do also B. So B minus A. Wait, what? A, B. A, B, B, A. Well, the largest one is 1 minus 3, and that's equal to 2. So we should have gotten that. and the other one is, the largest one is, or no, BA is also 3 minus 1, which is 2. Yeah, what the? Word 1, max 1 minus max 2. Word 1, word 2. So started. Let me just see something really quick. Oh, we expected 1, 1. Oh, okay. Damn, why though? Let's see. We wanted 1 and 1. Why? Because we have this. These are the closest ones. Ah, the largest this and the smallest this. Okay. That's what we really want. The largest starting point. So it's like the largest starting point and the smallest ending point. Ah, okay, I got it now. So I want actually the smallest starting point and the largest that. So let's try this. Okay, never mind. That just fucks up everything. Let me see. So if we do smallest starting point, right? So that's gonna be 0. Oh no, largest starting point and then smallest ending point. So maximize this, but minimize this. Yeah. Okay, a little better, but still wrong. Let's see. Because if I maximize BA, if I try to maximize BA, like this call is gonna try to find 3 minus, yeah, it's gonna try to do this and this, which is technically true, but if it was circular, but I don't think it's circular. So do I really have to try every single combination? I might have to do that. Let's do that. If that doesn't work, then I don't know the really solution. So let's try that. So basically what I need to do is so for every, I guess, shortest min, or we'll call min here. For every okay, so we need to, damn, this sucks. Time points for every I in range of, or for every I in range of length of, or yeah, for every I in range of 1, for every j in range of 2, res equals the minimum of 1I this is definitely not gonna pass, but if I don't really know. distance minus, well, of course, ABS this 2I or 2J res I think this needs to be float inf res or distance, and yeah, and return min. Yikes. It does work, but it's probably really long. Oh wow, that works. Okay, that works. Anyways, thanks for watching. I'll see you guys tomorrow. Peace.